And technically, Oleh has to go to sleep at some point. Hi, Oleh. How you doing, buddy?
Hey, it's great.
Good.
Everything is fine. What about you, Josh?
Oh, just fine. I'm excited you're here. I was very excited that we got you on the stream. So thanks to everybody who's joining us. I appreciate that. Obviously, I'm Josh Long. It's very nice to meet you. And we've got my buddy Oleh Dokuka here. Can you introduce yourself, buddy?
Hey, Ron. And first of all, thank you, Josh, for inviting me to another great opportunity to code and show how to use our socket. So, yeah, another.
Mother Josh.
Yeah, my name is Oleh. I'm working on Project Reactor and RSocket as a part of Spring Reactor team. So yeah, I've been there for a pretty long time, and I hope I will be able to explain all the things related to RSocket to you tonight, or to this afternoon, but it's tonight for me.
Right. So that's because you're in
Ukraine.
Ukraine, right? Which is far ahead of the day. Far ahead in the day. 9 hours, right? It's 9 o'clock, 10 o'clock there, something like that.
Yeah, 10.
10. Yeah. Okay. So 10 hours. Ooh. Okay. So we won't keep you all too long. All I want you to do is just to give us the tour. Right now, there's all this good stuff around RSocket. So you mentioned you're a recent. You just recently joined the Reactor team officially, right? But you've been a contributor for years, right? And one of the things that's really interesting about Reactor is that it supports the concept of reactive programming, which it supports which it supports because it gives us a protocol to allow us to define things like back pressure, right? Which allows us to write services that do the right thing on the web. And when I think of reactive programming, I think of these three big virtues, right? The three big wins or gains that you get. The first is ease of concurrence, right? It makes it easier to write multi-threaded, efficient code. More robust APIs, that is to say, APIs that do the right thing, even if there's service outages and topology changes and failures. And then it gives me consistency. So I have the same kind of data type, and that makes it easier to compose, right? I can take databases and network calls and WebSockets and HTTP and RSocket, and they're all just this one kind of thing called a publisher. So life becomes easier there. So reactive programming, super useful. And you can kind of do reactive programming with HTTP. Why isn't that enough?
I believe that because HTTP is not fair enough. HTTP has, or I would be talking about TCP better, because HTTP is based on TCP. So TCP has back pressure, but this back pressure is not that fair because it's based on prefetch, I would name it, or based on some positive understanding that you can send some amount of messages and the recipient side can buffer them. So this kind of works as a back pressure because at some point in time the buffer will be fully loaded. But if you have many connections at the same time, sending too many messages, your computer and the server can just blows up because all of these buffers will be filled up with messages and will take a lot of memory. So this kind of messaging where one side can send messages in advance without knowing for sure that the recipient can receive messages or not is not that robust as, for example, the model that we have in RSocket, like reactive streams model, where a recipient or a subscriber can directly say how many messages it's ready to receive without buffering, or buffering with understanding that the system won't crash. And the producer will know for sure that this amount of messages can be consumed safely. So this is the main benefit. Like you have reactive streams in your GVM or in any other like programming language. And then this kind of robust model is mapping on the network protocol. So this is the main power of it.
So the network protocol, you just described something very important there. You said that the consumer, the producer can be sure that that the consumer has enough to be able to receive the messages that you're going to send. And the reason is because in the reactive streams model, the client the consumer requests the amount of data that it wants. It can say, I want 10 more records, I want 1,000 more records. So it's in control of its own fate, right? The producer is not able to dump more than the consumer wants because the client initiates the conversation. The client initiates the request that asks for more data, right? That's so it's not just some sort of like metadata field. It's actually the consumer explicitly requesting more records, and as it requests, then the producer produces that data. So that creates a situation where the producer is never going to go faster than the consumer can handle.
Exactly.
Because it drives the rate. Okay.
Yeah.
So why isn't this good enough for us as a TCP, like or HTTP for that matter? Like since HTTP is based on TCP, why is it limited? And in contrast, why is RSocket, which is also based on TCP, not limited in this way?
First of all, it's worth to say that RSocket is not based on TCP. RSocket is beyond just a simple layer 4 network protocol, because it's a little bit higher. It's layer 5 and layer 6 network protocol based on OSI model, which means that it can use any network transport, like binary network transport, in order to deliver its messages. Which means that it's even more than HTTP, which is bound to TCP nowadays.
Right.
But a part of that, like HTTP evolution has shown that HTTP is not that good. At the very first days of HTTP, we got like HTTP 1.0, which sound like a pretty cool protocol for requesting data from browser, from server to browser. But then it ended up that we have to open too many connections, which is not that good, because server doesn't have the capability to handle unlimited amount of connections at the same time. So the folks invented HTTP 1.1, which was designed to improve or reduce the number of created connections, but using techniques, so call it pipelining, where multiple requests can be offloaded to or sent over a single connection. But this technique was also not the best, because people started observing problems like head of line blocking. And basically it means that if multiple requests was issued, then all of them has to be stuck waiting for the first entered to be completed. So it means that if you issue multiple requests, but the first one is too heavy or takes so much time to produce a response, then the other, which might be faster in terms of responsiveness and latency, have to wait for the very long one.
So that's not really that's not very good multi-threading then, or multiplexing, right? That's just...
Yeah, and they invented HTTP2, which kind of has to solve all the problems. But again, HTTP2 doesn't have that fair break pressure as in RSocket. It uses the same mechanics as in TCP, where a producer has like this window of bytes it can send in advance without knowing and understanding that the recipient can or cannot consume them at this point in time.
Okay. So it's still kind of a guess when HTTP consumers consume data as to whether they can actually handle that amount of data.
Yeah.
Right? There's no sequencing there. Okay. So this protocol it goes beyond the limitations of HTTP, and just generally, even if I started the conversation by comparing it to HTTP because I feel like everybody will know about that. But there's a lot more to RSocket than just a better HTTP, right? It's a binary protocol. It's a network protocol that is payload agnostic. So, for example, it's not like gRPC where you have to have Google protocol buffers for all the payloads. It's bidirectional, so there's no real client server. It's actually requester, responder, but either side can be either thing, a requester or responder, right? It supports multiplexed communication, like you described. So one open socket can handle multiple requests, which means that you don't have to recreate new sockets every single time, right? Which is one of the problems with HTTP 1.x, which is that it sometimes can be very slow to make a constant network connection, establish the call, ACK, do all that stuff, and then make the request and response. It supports the concept of back pressure on so the wire protocol itself has a way to tell the consumer, like we just talked about, it has a way to tell the consumer about whether it's got more or less data, right? This is not just relying on buffers and TCP. This is it's in the protocol itself, right? It's aware of the payloads as well.
Exactly.
So it's really just a very rich protocol. And what was the sort of background? Like, where did it come from?
So initially, all of these problems that you mentioned related, it's not even problem. It's just limitations, because when folks were designing the HTTP protocol, the HTTP2, they didn't have all the understanding of today's cloud problems and cloud computation and how it's going to be used in microservices. So they had some ideas, but the picture wasn't full. And then Netflix started using all of this cool stuff. They started using HTTP2, they started using gRPC, and then they started observing some problems related to edge network, like to the cases where they have a server hidden behind a gateway, which plays kind of a proxy role. And then they have thousands of clients or consumers, which is mobile phones connected over different like networks with different stability. And they started streaming many data, a lot of traffic, and their gateway just started crashing because of out of memory or other problems related to the fact that there is no end-to-end backpressure where a consumer can directly say through the whole pipe of services, through gateway, another service, and another service, that this consumer is ready to consume, for example, 25 elements at this point in time or more. So this problem wasn't solved. So Ben Christensen and his team, cloud network, edge network team, started working on the protocol based on this idea of reactive streams. And Ben Christensen with his team, with Todd Montgomery, created the first version of reactive sockets.
So for people who don't know, Ben Christensen was one of the main people behind RxJava, right? And Todd Montgomery works on Aeron, right?
And it was mentioned that Todd Montgomery was designing protocols for NASA to communicate between Earth and all of this kind of space stuff.
Right. So two really qualified people who understand reactivity and network protocols. The best of the best. Okay, go on. Sorry.
Yeah, and they started thinking about protocol with fair backpressure, with multiplexing semantic. Basically, they started designing HTTP2 with backpressure and some bidirectional communication features, and these semantic types of requests where you don't when you're not limited to just stream, where when one side want to stream and another side want to stream, but neither of them knows how many messages will be sent from one to another. So they created HTTP2 but better, with backpressure, with clear semantic for your request, like a single request and a single response, a single request and multiple response, or multiple request and multiple response.
Right.
So that's basically the background. They created RSocket. They started using for various of services. I don't know if they still using it, but at some point in time, Ben with his team decided to go to Facebook, and RSocket started being used in Facebook. And another part of folks created a company which started working on RSocket protocol and building it, kind of building on top of it a product.
Right.
So that's the background.
Awesome. And so that company, Netify, very awesome company. They did a lot of work to make RSocket even better, right? To take it further. And then, of course, around the same time, well, not the same time, later, the Spring team sort of learned about it, right? We learned about RSocket and loved it. So now this is unusual in that this stream that we're going to have today, that this discussion that we're having today, is not about a thing in the future. Mostly, a lot of it is just, it's already stuff you can do in Spring right now. It's been in Spring for more than a year as a GA thing, and it's been in development for a couple of years. Since I remember we talked about it first at Spring 1 2018, was it? So
yeah.
It's been a while, right? It's been a while that that we've had it there. So that's cool. So that's the history. I want people to know about that just so we can appreciate what we're going to talk about today. And today I wanted you to help me kind of see the new stuff, right? So there's a lot of, I mean, it wouldn't be bad to look at some of the old stuff very quickly just to see a basic example. But then can we look at some of the new stuff you're working on? You're working on RSocket all the time, right? Not just the Java implementation either.
Yeah, so yeah, to clarify, I'm working on RSocket. This is kind of my main focus, but of course, we heavily rely in RSocket Java on RSocket on React Native and Project Reactor, like Reactor Core. So a part of RSocket, I'm helping with Reactor Core and React Native.
Okay, cool. So that means that we both benefit. The RSocket and the Reactor teams both benefit. Cool. Can you show us some examples of just RSocket in action in Java, and then maybe we can look at it in Spring quickly, and then let's focus on the new stuff. Like
sure, absolutely. Give me a second. I'm just going to share my screen. Can you see it?
Yes. Whoa, cool background.
Yeah. So let me. I've been playing with RSocket Kotlin, but yeah, we will be looking at RSocket Java today. But something that you just haven't mentioned is that RSocket is not only in Java. It's a protocol. It's like language agnostic. It's implemented in various languages. It's implemented in actually we updated our web page, as you may see. But in any case, we have a new fresh view. It just happened today. So we have Java, we have Kotlin, we have JavaScript, we have Go, we have Rust, .NET, C++, and we are working on Swift. So more and more is coming.
You lost me after Kotlin. I don't know what those other languages are, but I'm sure they're nice.
Yeah. So yeah, I just opened the RSocket Java repository, and I did that because we have various of examples here.
Yeah.
And basically what like every average developer want to do in order to start using RSocket is of course bring in dependency. Here you can see like a local or relative dependency on RSocket core and on RSocket transport netty, and we have various of other transports like local via some like in-memory queue, or we have but actually I'm working on other implementations like transport Aaron, but this is another feature and it's not ready for production at this moment, but it's coming.
Cool.
So in general, you want to bring RSocket core, you want to bring RSocket transport netty, and that's your getting started stuff. And
now, if you're a Spring user, you just go to start.spring.io and choose RSocket. You'll have all the same types.
Yeah, and that's much easier way to start using RSocket because you have all of your well-known convenient annotations and best ever Spring framework for doing all of this job for you. But in general, in order to start using, for example, RSocket, and in order to do a simple, let's take a look at request response. This is a hello world example. So what you want to do, you want to define a server, you want to define a connector, but this is not the main thing. As just mentioned, we have two core things. The first one is a payload, and payload is a binary thing. It's just interface which let you consume data as a buffer, is a binary data, and consume metadata in the same way. So it's fully binary protocol. In RSocket Java, we rely on the native byte buffers for efficiency.
So the native byte buffers, this is kind of an interesting point. Netty, of course, is this library that was designed to support creating asynchronous IO-centric network protocols. And there's this concept of a buffer, which a lot of different frameworks have, right? But Netty has them because they work a little differently. It's up to the implementation to actually manage the release of that memory, right? It's not like like for example an input stream or something like that, where if it goes out of scope or whatever, it'll just automatically go away. So okay, go on.
Yeah, so this is kind of one of the main things. It's your message. So payload is basically your binary message, which has headers as a metadata, and payload as a data. And another thing, of course, is your reactive API, which is exposed as mono or flux. This is part of Project Reactor.
I have a question. I have two questions from the
Sure.
From the audience here. Okay, first question, friend. Guy, people, one question about RSocket connection model. Let's assume application A is interested in calling some different endpoints in application B, and that all calls are simple request response, not stream. Does RSocket still open only one question at startup and send all requests through the same persistent channel, or will it reconnect every time for every request? Is this behavior configurable?
Yeah, I believe that the answer is that since RSocket is multiplex protocol, it's designed as HTTP2, it will send all of your requests through a single persistent connection.
Cool. And the second question is, if there's a JavaScript implementation, does that mean that RSocket doesn't require threads?
What does it mean? I mean,
if test threads are just managed by the runtime, right?
Yeah, I think so. I mean, even in RSocket Java, we use kind of native runtime, if I can name it, which uses even loops or multiple even loops in order to consume data from the network.
Right.
So the model is non-blocking and asynchronous in all of the scenarios. In JavaScript, we have JavaScript runtime, Node runtime, browser runtime, which uses event loops as well, and perform all of the kind of data sending and data consumption within a single event loop.
Right.
Yeah. So
the difference is that with Java, you have to set up the event loop, whereas with Node, you are inside the event loop. You don't even realize it, but it's there, and the semantics are the same.
Yeah.
Absolutely. Okay, good questions. Thanks for that, Oleh. Sorry to interrupt. Carry on.
Yeah, sure. And the second thing, like the third thing, a part of your API with which you have to work, the third thing is RSocket abstraction, which brings you 4 main interaction types or request types, which is fire and forget. So you just send a message to the network, and you don't have to wait for a response. So you can just send messages, and you don't care if it's dropped on the server side or it's consumed, etc., etc. You just need to send it to network. Another one is more reliable. It's like request response. So you send a request, and you can wait for acknowledgement or real response data, like you query some database, and database send back, for example, an item. Then you have request stream, so you can open a real live, potentially infinite stream of messages, a synchronous stream of messages, and consume it via Flux. And the fourth one is basically request channel, where you can open a kind of a channel, like multiplex channel within a single connection. You can start streaming data to recipient, to remote recipient, and at the same time, remote recipient can start sending some responses back, which is awesome. So it's bidirectional requests, basically.
Right. So the types that you've just introduced here, just a quick pause. You look at publisher, that's a reactive streams type, right? Publisher comes from the reactive stream specification. And then mono and flux, these are 2 publishers they're specializations of publisher from Project Reactor, right?
Yep.
And so a mono is a publisher that produces at most 1 value. A flux is a publisher that produces potentially unlimited values, right? 0, 1, 2, 5, a trillion, infinite, etc. Okay.
Yep. Correct. And basically, so this is the API you have to work with. And this API is pretty similar in all of the implementations. So if you learn, for example, RSocket Java, then you will grasp easily all of other implementations in GS or in, I don't know, in CPP. In CPP, it's a little bit harder to understand what's going on there, but the API is pretty similar. So using this API, you can do calls, and you can define your handler, which will do some business logic. For example, if you got a request response, then you can return a mono, which will be like providing some feedback. And you can create, for example, you can use default payload, and you can provide some echo response saying that you have already successfully consumed your data, and we have a various of useful methods which allows you to consume your data as a stream, and you can do the same as a response. So this is kind of what you can do easily. But this API is, so this is a beginning. In order to start using this, you have to define a server, and basically the server have like pretty cool builder style builder kind of API where you can provide your acceptor. You can say, okay, this is my events or request handler, and this is this RSocket. And then you can say, okay, so this is my business logic, but as I mentioned, RSocket is transport agnostic, and that's why we have to bind to a particular transport, and the API of RSocket server just say, okay, please provide me a transport interface implementation. And we have a various of transport implementation, and one of them is TCP server transport, but at the same time, you can easily switch your TCP server transport to WebSocket server transport. Or for example, if you want to just try it inside your local machine, inside your GVM, same GVM, you can say, hey, local server transport, server transport.
I've never used that one. I didn't know that was a thing. Is that new? Has that always been there?
No, it's always been there. So you just never. Yeah. So you can say, okay, I want to use local server transport. Underneath, it will create just two queues, like just two queues, single producer, single consumer queue, and the communication will be done through that queue. So it's really cool for testing, for example. You don't have even to run a server.
Wow, that makes unit testing a lot easier.
Yeah. And then, for example, okay, let's come back to TCP, because everyone wants to see real communication over the network. So at the same time, we have client or connector, and that's the only place where you will see client server, because after that moment, once the connection is wide, you will see peers. So the connector is capable to define a transport as well. This is kind of a shortcut. The longer version, it looks like this. You can say create. You can provide accept as well. So technically, you can say socket acceptor with the same RSocket, and both sides will be able to do the same. So it will be real peer-to-peer. And then you can say connect, specifying the transport you want to use to connect.
And the connect and connect is the thing to which you were going to make a connection. Okay, yeah.
Yeah.
You're not binding to.
Yeah, the server is binding to a transport, and a client is connecting to a particular endpoint using specified transport. And then once you successfully connected, I'm using here block because basically we are waiting until the connection is wide, but just in case you don't like block, or you don't want to block in any place in your code, you can do something like flat map, for example, and you will be able to receive socket here, and then all of your actions will be done like this, or something like this. Of course, I have to return something, which can be, for example, return, come on, mono.never, and subscribe.
Yep.
And that's it. So of course I have to align my code a little bit, but yeah, I don't need that. That's basically it. And if we're gonna start it, or we don't even have to use block here as well, that can be improved. But for demo purpose, I will go back to the original example just to show that everything is working properly. Come on. Yeah. And if we're gonna run it, I'm running it, we will see a server started. And we will see a couple of responses coming back.
Nice.
So we see echo hello, echo hello, echo hello. Of course, we can add some useful data like I, and it's gonna be like more understandable which request we got back, but you can see that it works. And in order to start using it, you don't have, it's not a rocket science. It's available for everyone.
Right, and it works like you would expect any old socket to work, except it just, as we've talked about, it has some significant advantages. Now, what if you look at that code where the server is accepting the incoming request, right? The RSocket server socket acceptor. We have another question from the same person who had one earlier, and I think this is maybe a good time to ask about it or to talk about it. Let's say thousands or millions of requesters are sending requests to a responder. Does that mean that the responder side has to maintain all of those persistent million connections forever? Or does it have configuration to drop idle connections? And how is performance affected while maintaining all these persistent connections?
So first of all, of course, a single machine won't be able, like billions or thousand hundreds of simultaneous persistent connections, because like a hardware is not capable to handle that much because a single server can open like 65K like sockets to observe connections, and I don't remember for sure how many connections it can accept, but it's a limited number. Of course, it can be tuned, but keeping like persistent connection is expensive, of course. So the strategy is up to the implementer. The main benefit is basically the fact that you can handle and you can multiplex many requests from the same client without need to open connection, because opening connection, doing TLS handshake, and that's the operation that we do today on every like request basically. Or if we use HTTP2, then we do that once, and that's the main benefit of HTTP2, like multiplexing. And your current server, which uses HTTP2, opens persistent connection. You just think that this is not persistent connection. It has timeout if your client doesn't send, for example, requests. And you can implement with RSocket the same logic. So if a client doesn't send requests for pretty like significantly or like meaningful period of time, like 15 minutes or 5 minutes up to your configuration, you can drop this connection and that's fine. So you don't have to keep all of this connection alive all the time. You can drop it, and this logic is available for your configuration.
Okay, cool. So, okay, does that answer? I think that answered the question.
Yeah.
Pretty well. And then, oh, by the way, Spencer, our buddy Spencer, joined in and mentioned that at that scale, you want something like a broker, which of course we're going to talk about in a minute here as well. So, okay, so you've got this really simple RSocket client and server, right? And up until like 10 years ago, I couldn't have written something as simple as this, even for HTTP, right? Now there's a HTTP server in the JDK. It's not great, but whatever, it's there, right? The point is you could do it, but it wouldn't have anything close to the production readiness that RSocket has. And this code is trivial. There's no code here. It's very small, what you've written here. So it's easy to understand. It's lightweight, very approachable API. You just read it and say, okay, I know what's happening there, right? Sounds like it looks like a really easy protocol to get started with. How could we get, could we make it easier? What could we do to make it simpler? Can we look at like the story in Spring?
Yeah, but I believe that the best on doing that is you. So you can start from your start.spring.io.
Yep. Okay. I'll do a quick demo of that. Assuming, of course, that let me change my monitor resolution here. Sorry.
Or if you want to do me doing that, I can do that as well. But
okay. I mean, you could do it as well. So we're gonna do the broker in a minute, right? But just that way I won't be accused of not helping.
So you wanna run Broker.
Well, let's do that in a minute. For now, I'll just do a very simple demo that we can go back to your screen where it's nice and safe and everything works well. Okay, so producer, right? RSocket, same old. And anything else I need to change there?
I don't think so. You can add Webflux in order to run RSocket as a part of your Webflux server. So you can have RSocket and Spring Webflux at the same time, and you can accept your convenient HTTP request, and you can accept like a WebSocket connection and do RSocket over it.
Okay, so I've got both. I've got the reactive web and I've got RSocket Webflux as well. So okay, you're saying there's also a Kotlin thing. We should talk about that in a second. Is that usable? Is that like something we can try later on?
I guess Kotlin integration with Spring is used in RSocket job in any case. It just brings Kotlin API for programming, like for coding. RSocket Kotlin is a totally different kit. We can take a look at it.
Right.
I can explain the API, and you can see like the power of Kotlin and all of these Kotlin features.
Cool.
Yeah, but
let's try a simple Java Spring one, then we'll go to yours and we'll do Kotlin.
Sure.
So here's producer, and here's consumer. Okay. So we want downloads, producer, okay. So the producer, we'll just do a simple, make my font larger here. Okay, so very simple. This is the thing it's gonna act like a server. It's obviously, it's gonna be a producer, right? But the thing that's confusing about RSocket is that it doesn't necessarily mean that this always is a server, right? The client can actually act as a server as well. So I want to create a RSocket server. I'm going to create an RSocket controller. So, greetings controller, and it'll just be at controller. And this controller, I'll just have a message mapping endpoint. So hello.name, mono of string hello, and destination variable string name, mono.empty or mono.just hello. You know what? Actually, map of string collections.singleton map greetings hello name. There we go. So this is more or less equivalent to, the simple hello world we saw earlier, right? In order for this to work, I need to tell Spring Boot to create the RSocket server. That's one thing that I often forget, and if I don't have that, it won't work. So make sure you add this. And if you run this just by itself, as it is, there we go. There's our application. So now, if I want to talk to it, I can use this great command line utility called RSC by our colleague and friend Toshiaki Maki. So github.com. Here it is, right? So RSC is a really convenient command line CLI that aims to be like curl for RSocket, and I find it to be invaluable. So I want to talk to that service that we just wrote. Yeah, so I've got hello, and then I can say request response, is it? And route is TCP localhost 8888. Sorry, route is hello Oleh. Okay.
Yeah.
Request response RNR maybe.
Can be.
I think it's the default actually if I just leave it off. Oh, there you go. So there you go. There's my simple RSC call, right? So I'm saying call this host and port. Normally, if you want to change the stream type, like earlier you talked about the stream type with the RSocket interface, right? If you look at RSocket, you talked about the stream type. There's request response, request stream, request channel, and fire and forget. You have to be very explicit about that, right? The client has to specify how it expects to engage with the controller, with the service. And so here, it's just a single value being returned back in response to a single value being sent in. So it's request response. But for example, if I did mono void, well, that's no response. There's no value there. So that's fire and forget. I'm sending a value in, but I'm getting nothing back. If I had done a flux of whatever, then I would say that's a stream, right? I'm making a single request in, but I'm getting back multiple values back. So that's a stream. And then if I had gone further and I had said I wanted a stream of values coming in and a stream of values going back out, that's called channel, right? So you have to be aware that these signatures that you create here map more or less to the stream types. And that stream type is important. You have to actually specify it here. So for example, if I was making a stream call, I would have to say stream, or I think it's fire and forget. I mean, there's shortcuts, but since I do stream so often, that's the one I remember off the top of my head. Okay, so there's the producer, and the consumer is even easier. So and now here I need a consumer. I need a thing to act like a client, kind of. And so I'm going to create what's called an RSocket requester, right? And this I can do by just injecting the builder, localhost 8888. And one thing I think important here is that arrangement there, that listener is going to stay connected for the life of the application, right? So the client will this consumer will start up and it'll stay connected with the service. What happens if something goes wrong? Am I able to retry? How do I reconnect if something happens?
So is it a question to me?
Yes.
So in general, you have two things to use in RSocket requester. You have to in builder. First of all, you have to do that in builder. If you wanna, for example, if you lost your connection and you wanna reconnect, there is a configurer. So if you can specify like a configuration for underline RSocket. I don't remember. Can you list? No, it's not there. It's not there. You have to do that in a different place.
Oh, not in the builder?
In the builder. Yeah, so what do we have here? RSocket connector configurer. Yeah, that's what we need.
This one.
Yeah. So if you can create this one. And then you can use RSocket connector. Reconnect, and we have like a property reconnect. And you can specify a retry strategy here. And just in case you lost your connection, this kind of feature will take care of everything, and you will be able to reestablish your connection.
That is awesome. That's new too. I don't remember that being there.
Yeah, that's kind of pretty new.
So okay, wow, so that it's one connection, but if it loses the connection, it'll reconnect. You can configure that. You saw how easy that was. And notice that this is the same retry from Reactor, right? This is not actually. This is from Reactor itself.
Yeah.
Yeah, there you go. So if you're doing, let's say I have a regular stream of whatever, test, right? Test dot retry. And it's the same one. I can actually do 10 duration of seconds, whatever, right? So that same retry type is usable across any of these reactive APIs, right? So that's what this is. Save that, private, final, whatever. And I can do any regular stream will support that, but I can also use that same exact thing here when configuring my RSocket connection. How cool. Okay, so this is the data, and I'm going to send the data. The data, there's no data. There's actually just a route, a destination variable. So the name will be Tanzu. Twitch.tv. Okay, so we've got that, and then what else do I need? No data really, just send, I guess.
Yeah, send. Or you can call retrieve because you want to retrieve, for example, a stream back.
Yep, that's true. Better yet, string.class and result response result. Okay.
Yep.
Good. Okay, so there's my client to talk to the server, so to speak. So that's the producer. Let's do this consumer. Oh, the other problem that we're gonna have is that this is not gonna, well, actually, no, it'll create a web server. That's fine. It'll create an HTTP server, which might have a conflict. Yeah, the HTTP server is useful because it creates the process which keeps the thread alive. On the other hand, it needs a port. So
yeah.
Okay, now what happened? I did something wrong. Greetings, hello. Wait,
something went wrong with your. I don't think the problem is in here. Yeah, it's related to start, and you got a response. The exception is from a different place. So yeah, whatever it says, you got a response, which means it works.
You know what? I'm running on my Apple Silicon Mac. Is that? Wait, look at that. I wonder if is this native code that isn't currently supported in the brand new Apple Silicon Macs, which are completely brand new?
Can be.
It could be something as simple as that. I've written this code a million times, so I know it works. Route, hello. Do I have the right host and port? Localhost 8888.
Yeah, you've done everything correct.
And this wouldn't make a difference?
It still works. I mean, you may do it another time.
Yeah, it's the DNS resolver. What is that?
Yeah, can you see underneath, can you see like below this exception, you can see response printed out.
Yeah, greetings, hello. What is the deal with that? Huh.
Can you just specify like a certain and concrete port instead of like 0? Maybe it's because of that.
HTTP? Yeah, sure. Whatever. Oh, is that what it is? Server.port is broken? Oh, thank God. Okay, what? No, that doesn't quite do it.
Maybe it's a bug in React.net related to new, I don't know.
Brand new hardware, completely different platform. Okay, but I'm curious about this. Let me just try one thing here.
Sure.
Maybe even re-import and then go here and we want to say, where's my public static void main?
No, I guess we're still using React.net underneath, even in case of RSocket. So
that's super interesting. It's DNS though? Why? What is that?
Actually, this exception comes from it's client transport. Where it comes from? Can you scroll up?
macOS DNS server address resolver. Lambda.
Oh, it comes from RSocket side. I don't know what is the root cause.
That's interesting.
Yeah, maybe we in RSocket doing something wrong in terms of configuration.
Well, it is just okay. Wait, let me get rid of that for a second. Huh.
No, it's not related. You can try WebSocket, for example, instead of TCP. So you can REST specify you can say spring.rsocket transport on the server side. Not
on the
here.
server side.
Yeah, on the server side.
Socket port.
Transport, yeah, and you can specify here WebSocket.
And that's it? Just restart?
Yeah, that's it.
And what about in the consumer here?
And instead of TCP, you can specify WebSocket on the line 31.
Right on WebSocket. URI.create. What's the WS something?
Yeah, exactly.
Okay. What's the?
And yeah, you have to specify like colons, yeah, like URI, and that's it.
Okay.
And one bracket on the right, yeah.
Thanks. Okay, run. That's interesting.
I don't know what is that.
Wait a minute, 404 not found. Is there an endpoint I'm supposed to use? Like a
I guess you have to connect to 8888, not to 8080.
Okay. Got the result though.
Yeah, but I just want to mention that changing transport and switching from TCP to WebSocket with RSocket is as easy as pie.
Super easy, yeah.
Yeah.
Super easy. I'm gonna try something. I'm just curious. Did we break this before? It's still working. That's what gets me. Is I really am sure I've done this before. If it's not RSocket, like if it's not the issue that RSocket is changed, right? Then something else. Spring Boot starter parent. Oh, dot release. This is before we changed this. Okay. I'm typing R, but I'm not getting an R. Okay. Maven, reimport Maven.
Yeah, I guess you have to remove the space in the version, haven't you?
It doesn't matter, but yeah, okay. Let's see, Maven, reload. Okay. Did I make a mistake? Is that not start? Is it 2.38? 2.39.
It's yeah, to the 3.8, not 9.
Oh, I got ahead of myself. Downloading the world. Okay, good. Run. Right, so we need this to run first. Stop and rerun.
Actually, you don't have to do that. With Reconnect feature, you can run a client, and client will be retrying continuously, try to connect, and then you can start at some point in time a server, and client will connect it, and you don't have to do anything at all.
And I just had to use the old DSL there.
All right.
There, isn't that weird? That worked better. So there's something new.
Can be.
Yeah, I had to use the old DSL, connect WebSocket. I could swear I've done this. I've done RSocket on this Macintosh before. So something 2.4.1 maybe.
I believe it can be related to Reactor Netty.
I mean, sure, it's not a big deal. I'm just very curious about this. Okay, so the point is, what we've learned is we're not going to do the rest of the demos on my Mac. We're going to do it on yours, which is what 99% of the world is going to be using, right? That's
yeah.
Or a Linux machine or a Windows machine, but they're not going to be using this brand new untested platform. Okay, so let's see. It's got 2.4.1, right? So we start this. And this one still compiles, but it's got the old API. So WebSocket, goodbye. Okay, take 2. Yeah, oh, look, 2.4.1 works just fine.
That's awesome.
So, okay, so just 2.4.2, there's a little, we found a bug, yay! Only on the Mac. I think it only applies to my stupid Apple Silicon. I'll bet it wouldn't apply to my other Macs. So, okay, good. So that's a producer and a consumer. So can we look at, we've got actually, can we skip it? We've got like half an hour. So can we look at the broker? Can you take us to a tour of Broker Town?
Well, that's interesting. I would have to find an example from Spencer's. Yeah, basically from Spencer. Or either I have to look into my old examples. But yeah, definitely I can try doing that.
Awesome, if we can. I'll talk about the broker way you look. The idea here is pretty simple, right? In principle, what we want is we've got this ability to create a connection. We've got the ability to create a producer and a consumer. They can talk to each other directly, but sometimes in networking, as in architecture, as in life, a little bit of indirection can be very useful. So wouldn't it be nice if there's a broker through which you could route requests intended for other services that could do things like load balancing, that could do things like proxying, that could do things like enforcement of security policy or routing or retries or whatever. And so that has some really interesting implications, right? And we can see that in the RSocket broker, which is a sort of an effort being done here. RSocket routing. Is this right?
Yeah, that's basically the place related to broker. It's called, like, we've been talking today with Spencer about RSocket routing and forwarding, and in general RSocket router and routing, which is like a mechanism for just defining like your URL, like hello dot something, like hello.world, and then your route is being delivered to a particular destination, and that's routing. But RSocket routing sounds pretty similar, so many folks are wondering, okay, what is the difference? And in fact, RSocket routing has to be called as RSocket broker, because this is a specification which defines like a mechanism, a separate mechanism, which is built on top of RSocket in order to make your communication transparent. Like we have these principles in reactive system, like elastic, resilient, and messaging. So your system has to rely on messaging, and messaging has to be transparent. So your sender doesn't have to know like a physical IP address of your recipient. It can say, okay, I want to deliver a message to Josh, for example, and your like underlying system has to do that. So RSocket routing and RSocket broker is exactly for solving this problem. It uses RSocket as a transport in order to do messaging, efficient messaging with different type of communications, but it allows a client or a requester to just say, okay, I want to deliver message to this endpoint, which is like message service, for example, and that's it. And then it can define a specific route within a call, and then this request will be delivered to one of the available destinations. So this is a cool.
Yeah, go on. Sorry.
Yeah, this is a cool part of RSocket broker, and I'll try to find ping-pong examples. For example, in one of the driver and leader of this project, which is Spencer.
Right.
So let's try to find a ping-pong. Oh yeah, we have RSocket routing sample. What a great
ping pong.
Yeah, and I'll be doing that quickly. So git clone ping pong RD RSocket routing sample, and I'll be explaining all the bits related to where that.
Come on.
Okay. Opening in the screen. All right. Yeah, it's an old description, because initially this effort, which became like a public and open sourced, fully open source, initially this idea of RSocket gateway, not RSocket gateway, but RSocket broker was developed at Netlify. So we've been working on a product called Proteus initially, but then we called it Netlify broker. And then once Netlify has been terminated, last year, like part of the effort was kind of, and the idea behind Netlify Broker was kind of reused in not reused, but basically taken into Spring Cloud Gateway, because Spencer was working in parallel with us in Spring Cloud Gateway, on Spring Cloud Gateway, RSocket Broker, and then this work was just moved into RSocket routing organization as a public effort.
Right.
So we have it now available for everyone, and everyone can try use it. Now I have to figure out what's going on with my Maven in order to show some code.
Resolving dependencies is downloading the world.
Yeah. Oh. So we have to wait a little bit. But now, as I said, you can easily start using open source version of RSocket Broker. You can actually, RSocket Broker right now is well integrated with Spring. So let me just show it into repository while dependencies are downloading. Yeah, so what we have here, we have like a vanilla RSocket routing client where you can like start a client, connect to a broker. You have to configure all this stuff on your own, but at the same time, Spencer created great integration with Spring, so you can just bring extra dependency into your project, and you will be able to use your familiar RSocket requester, and you will be able to specify like a destination name in addition, and that's it. So basically, you're using the same Spring messaging. You're using the same code that you've been using a while for now, and now you will be able to easily kind of migrate it to fully distributed reactive system.
Yeah.
So this is cool part. Okay, it's still downloading, and at the same time, RSocket Broker has the same structure. So it has like a vanilla RSocket routing broker. It's a library which has to be ran and configured, etc., etc. But a part of that, you have like this RSocket routing broker module, which uses Spring messaging underneath, which uses all of this cool Spring developed stuff. Right. And you can start Broker as a Spring application and do all this.
Broker or something like that?
Say it again?
Like @enable broker or something like that? I don't know. What is it?
I'll show you.
Oh yeah.
It's still downloading, but I guess I can.
We can do Sublime or something.
Yeah. So, for example, yeah, gateway is here. So you have to bring. Well, it still depends on the old API. Let's have a look. RSocket routing. So I have to switch a repository to show the new stuff, I believe. Yeah, here we have Broker, and yeah, this one, I guess, in this place we have the configuration for all the stuff. Yeah, we have it here.
Oh, it's so cool.
Yeah, so what you have to do, basically, let me find it. You have to define like this is dependency. This is dependency management. But in order to define your broker, what you need to do, you have to bring this starter RSocket into the place, and then you have to bring RSocket routing broker Spring, like it's a Spring integration for RSocket routing broker, and that's all you have to do. As far as I remember, you have to just say, okay, Spring application.run. It's running the normal Spring application, and in your configuration, you have to specify a couple of things related to a broker. So since broker is a fully distributed system, it has to know where is other brokers, because if you define only a single broker, then the broker will be like a bottleneck. But you don't want to have a bottleneck in your distributed reactive system. The reactive system shouldn't have any bottlenecks. It should scale. It should be elastic. So you may define multiple brokers, or you can even rely on some discovery service in order to discover other brokers in the network. So it can be a couple of solutions. It doesn't matter. So you have to define in your configuration where is the broker 1, where is the broker 2. You have to specify IDs. You have to specify ports for your TCP traffic from your clients and for cluster traffic, because as I noticed, broker is joining into a cluster and has to communicate with each other and share the information they have. So this is a separate story. This is less interesting, but all you have to do is basically that. You have to define ports, you have to define a couple of IDs, and that's it. And then, so this is one part. And then you have a client, and a client depends only on the same set of the like things. Instead of broker, it now depends on a client, which is Spring Client, and that's basically it. And in its configuration, what it has to do as well, it has to define IDs. It has to define its own service name because it has to be identifiable for a broker. And then it has to define a broker to which it has to connect. So we have like a broker, we have a transport over which a client has to connect, and a port to which it has to be connected. And
so,
yeah.
So which module was this? Which project was this? RSocket routing client or broker?
So the first thing that I've been showing, it was a broker. So as you can see, I'm using here RSocket routing broker Spring. So this is a broker, like a server, a thing which accepts connection and allows doing all this smart messaging. And it has integration with Spring. Yeah. So this is one thing. So this is broker.
So what is the, okay, I've got.
Let me just run it.
Yep, please do.
So it will start as a normal application. So it's running. Yeah, you can see here we got like RSocket starting on transport TCP on port like 8002, and then for cluster traffic it starts on 7002. So now we have broker up and running. I can even run more brokers, but it doesn't matter. And then, so the broker is kind of one thing. And then we have clients. We have pin client here, like pin client, and pond client. And both has to rely and depends on RSocket routing client in order to start communicating with each other.
Right.
Yeah. So this is the second part. So this is a client part. But a part of just a client, we're still using the normal Spring Boot starter RSocket, which is a convenient dependency for Spring messaging RSocket. So is it clear so far?
Spring Cloud Gateway sample. Okay, I think you're okay. Yeah. Sorry, I'm getting concurrent information in my other ear, and I'm just like, okay, a little confused, but good. Go on. Yes, I'm sorry. You're doing great. It's my fault.
Yeah. So now we have this application. It's the same Spring application. It has, as I said, various of configuration in order to connect properly to a broker and identify itself in the cluster. So client has to say, okay, my service name is ping. I can specify, I don't know, any name here, but someone who will be calling myself would have to say that specific service name in order to access and get the response back from exactly this instance. And a part of service name is like a group. So you may imagine that in a big system you have like wallet service, you have, I don't know, orders service, you have like, I don't know, whatever other service. But every service can have multiple instances. It can have wallet service instance 1, wallet service instance 2, wallet service instance 3. And in order to specify and identify this specific instance, we can specify a set of tags. And every instance can say, okay, this is instance name ping1. But at the same time, if I run multiple ping services, I can have multiple number of them, and every instance within this service name can say, okay, my name ping2 or my name ping3. So all of them can be identifiable. And just in case, for example, a specific client or a specific caller want to reach out to a specific instance, it can precisely say, okay, this is service name ping and this is instance name ping2, and the request will be delivered exactly to that instance. So this is a power that you can do with RSocket broker, and I will show it to you a little bit later. At the same time, we have ponk service, which will be responding back to our requests, and the configuration of this ponk service is basically the same as you have just shown. It has the same message mappings, it has routings, it has the same like response definition model. So you can send mono as a response, or you can send a stream of responses back, and you can accept a stream of requests. So the model is the same, but now everything is much better. So let me run this this app, and I hope it's going to be runnable.
Fingers crossed.
Yeah, I haven't run this example for a while. So it says something went wrong. Let's take a look at it. I guess I have to specify extra profile. Yeah, default profile, one client false. What it says, let's figure it out.
Method does not exist. Are you using, is there a class path incompatibility?
Can be.
You've got two different RSocket requester types in the class path.
Let me just reload the file. Maybe it's Maven dependencies.
This is all super early, not GA, not generally, like none of this is, you know, you can guarantee none of this will, you know, there's no guarantee that any of this will work, right? It's all not yet done. So we're just taking a very early look at all this stuff. But I'm just so curious about it, because this is, to me, this is one of the most exciting things in the RSocket space right now.
Yeah, I just want to find where I define all of the dependencies. So project RSocket routing. Yeah, I just had a different view.
Yeah.
And now I want to specify instead of, yeah, for example, the latest version of RSocket, and let's hope it works. It's going to work for us because yeah, it should work in theory. Not sure. All right, we have a newer version of stuff. So let me restart a broker. And if the broker works, then the rest of the things should work as well.
Yeah.
Okay, the broker just has started. So let's run a ponk service.
Fingers crossed.
Once again, stop and run.
Come on. Oh, but it's not being used.
It's something weird. Unless we moved our socket client to core. Yeah, that's what we've done. Basically, we moved it to a core, but that's fine. Yeah. This dependencies is not even used. Let's run it again.
We've got 10 minutes to make this work. And to
yeah, it started. It has started. Oh, awesome. And yeah, this is one point service, but in theory, I can run more. And yeah, let's have a look, and let's take a look at our config, what we have. Profile pon 4. Yeah, this is instance pon 3. So in theory, I can do something like this. Come on, edit config. I can duplicate this ponk service and call it ponk service 2. And I can specify different ponk profile like ponk 4. And now I can start it. And we will have, two services up and running. And we can have a look at the broker logs. And we will see that, hey, 2 different instances with the same service name has been connected to our lovely broker. But the first instance has instance name as ponk4, and the other instance has name as ponk3. So right now we have 2 instances connected to a broker, and we can run more, as I said. And now we want to run pin client, which will be calling our ponk services. So let's have, through the broker. So let's have a look what's going on there. So this is our ping service. The ping service, once it's started, it receives like an event, application ready event. It has like various configurations. It's less interesting for us. And it has requester. This is the most important. This is routing requester. This is kind of a new abstraction on top of like RSocket requester, which allows you to specify extra things like you can specify requester route, and you can say like with normal RSocket requester, like ponk, like whatever request response. And then you have extra new configuration, which is address. And address is a virtual address within your cluster. And as you can see, I'm specifying ponk here. So I will be connecting to a ponk service, but I'm not specifying a particular destination. I can specify that by saying, as far as I remember, I can specify like, I can create new consumer, I can have a builder, and I can say, okay, this is metadata, and I can specify like a particular tag, and I can say, okay, we stack, I don't know, instance name, for example. Instance name, and that will be a specific destination. But if I don't want to specify a particular destination, and I just want to like balance through the broker my traffic between multiple instances, which is up and running at this moment, I would be using just address, and that's it.
So you've got you've got a service registry kind of, you've got a load balancer here, you've got a proxy already. We've got a lot of things that you don't need because you have this broker, right?
Yeah. And I can just start this application, and in theory it should connect to a broker and start receiving responses. So in order to see that our pin client has connected to broker, it's just connected. We got ping.
That's awesome.
Yeah, and now we can have a look at our ponk application 1 and see traffic. Yeah, ponk. And switching to the second one. Come on, why it doesn't receive any traffic at this moment? That's weird. This client. Well, it can be related to load balancer configurations,
right?
Because this thing is so powerful, so you can configure a load balancer here, and you can redefine. And I don't remember which one is used by default, but if it's weighted strategy, then definitely everything is fine, and it's okay that all the traffic is delivered to the first one. But if we're gonna try to run another ping service, we can see in theory that the traffic can be split. So let's hope it's gonna be like this. Let's run another one.
As you run that, I just want to thank you so much for your time today. This has been like super cool. We went from theory to the future, right? We went from everything from just the idea to actual practical, how it's used and what it looks like. And then we got to look ahead, looking at the broker and looking at some of the new stuff and in the API. Really, really, I appreciate it. I mean, this 80 minutes with you has been, I hope very illuminating for the audience.
And just want to say that now we are seeing traffic from ponk service 2 and ponk service 1. So both of them are kind of streaming. And if we're going to run more and more requests, they will be shared between each other. So this is the power of broker. You don't have to change anything. You're still using the same sprint messaging, everything that you've shown in your demo, and now you run really distributed system using RSocket and RSocket broker.
That's awesome. Thank you so much, Oleh. Appreciate it, buddy. Welcome. I'm so glad you're officially on the team now. It's great that we get to work together, and I really appreciate this. Paul, do you have anything you want to say, buddy, old pal, before we sign off?
I don't think we have Paul at this moment. It's just an account which is streaming.
He's done the right thing. He's probably away drinking. Thank you so much, everybody else. Thanks for your time, and we'll see you on.
Thank you, Josh, for having me, and yeah, see you soon.
See you soon.